What is water hammer or water surge in a system, and why is it so important to protect against it? Hi everyone and welcome back to our channel. I'm Martin from Flowtech Water Solutions, and today we're discussing what air and water surges are in a system and the risks they present. Firstly, what is water hammer or water surge? Well, water hammer can happen to any system that has pipework with valves, pumps, etc. that allow for the control of water flow throughout a building. The sudden closing of a valve can cause a high pressured shock wave or surge to travel throughout the pipework as the liquid is forced to stop or change direction quickly. In most cases, the surge in the pipework can be heard straight away and sounds like a knocking or banging of pipes. For high-rise buildings, the effects of water surges can be quite damaging and pose a serious risk. Each high-rise building will have at least one riser, which is the main pipework from the basement to the top floor, that connects the smaller pipework on each storey. In our example, we have a water pump set installed in the basement plant room of the building. As the water pump set is activated, water will be boosted and travel up the riser to provide a pressurised supply to each tap, toilet, shower, etc. across the entire building. If the pump was to stop operating, maybe due to a power cut, engineer's works or fault on the system, the water pressure in the building will gradually decline as the taps and such are open and the remaining water in the system is drained. As this water is coming out through open taps, this can create a vacuum in the pipework, depending on whether there are non-return valves or pressure reducing valves in each part of the system. When the power is restored and the pump begins to operate again and restore the system pressure to preset levels, the worst case is that the pressurised water is pushed into a vacuum and the water accelerates beyond expected design velocities. This will cause a hydraulic shock to the pipework, potentially beyond the test pressure of the system. These high pressures can cause weak pipework or connections to burst, causing potentially huge flooding and expensive water damage within the building. Not only is this expensive to fit, it means downtime to the building's water supply and is also serious health and safety risk to those people that occupy the building at the time of the burst. So, what can be done to avoid this? Ensuring you have a booster set with a surge protection feature is a great precaution. So when the pumps are powered back up, they are limited on one pump and gradually increase their pressure and avoid ramping up too quickly. As well as this, an air and water surge protection valve can be installed to the top of each riser. The device forces air through the anti-surge orifice when the system is filling, which allows for the deceleration of the oncoming water supply, thanks to the resistance created by rising air pressure in the air water surge protection valve. This softens the potential pressure spike when the AWSPV valve finally closes. The air water surge valve design ensures effective deaeration under all pipeline flow and operating conditions via either one of three discharge orifices. Now for the technical details. The air water surge protection valve is RAS approved and available in one standard connection size, which is 25mm or 1-inch BSP, and weighs approximately 4.6 kilograms. It has a pressure rating of PN10, a maximum temperature of 70 degrees C, 158 degrees Fahrenheit. The maximum riser pipe diameter is 200mm. The overall dimensions are 95mm wide by 337mm high. You can find out more about our air and water surge protection valve on our website or by clicking in the link below. That concludes today's video. For more explainer and best practice videos, please subscribe to our YouTube channel now. Thanks for watching.